In this video, we're going to be talking about some of the logical operators available in Matlab. You've probably seen many of these in your math courses, maybe in junior high or in high school, but we're going to be talking about them and how we can use them specifically in Matlab. So why do we need to know what logical operators we have available in Matlab? Because logical operators will allow us to construct conditional statements. So what is a conditional statement? Essentially, a conditional statement is like an arithmetic statement, except that instead of producing some value as the result of a computation, we're going to be asking yes or no questions and then getting the answer to those questions. For instance, is one number larger than another number? Does some name exist within a list of names? Or maybe, do you know the airspeed velocity of an unladen swallow? Right, each of these questions has a yes or no answer, and as we work through this, we'll be able to figure out how we can ask those questions in Matlab. So pretty much every programming language uses conditional statements in some way, but the syntax is going to be a little bit different depending on what language you're using. So here we have all the relational and logic operators available within Matlab. On the left-hand side, we have the relational logic operators. Okay, so these are your basic comparisons, right? You use these all the time in math class. So we have equal to, which uses the double equal sign. So is one number equal to another number? We have the not equal sign, which uses tilde equals. So if you don't know where that is, that's usually shift, and then the button up next to your 1 key on your keyboard. Okay. So that checks to see whether two numbers are not equal. Then we have less than, greater than, less than or equal to, and greater than or equal to. Okay, so these ones allow us to compare numbers. Predominantly what we would be doing with those is comparing numbers, though I guess we could also compare letters as well. On the right-hand side, we have our usually called boolean logic operators, or just logic operators. Okay, these allow us to compare true and false values. So we have the top is the logical and, so 2 ampersands. We have the logical or, which is 2 vertical lines, and then we have the not symbol, which is again the tilde. We also have the 3 down at the bottom, the exclusive or, the element by element and the element by element or. We won't really do too much with exclusive or, and we won't talk about the element by element and or the element by element or until later on in the semester when we start talking about arrays in more detail. So the relational logic operators are pretty straightforward, but you may not be quite as familiar with the logical operators, though, as I mentioned before, hopefully you've seen these at some point in middle school or in high school in a math class, though you may not have thought about them since that point. So here we have a table showing what happens for the and, the or, and the not, given different sets of inputs. So our inputs are A and B, and they can take on values of true or false. So 0 indicating a false, so 1 indicating a true. As you can see from this table, the only time your and is true is when both of its inputs are true, so that very last line there. Otherwise, and will produce a false. If you look at the or column, the only time or is false is when both of its inputs are false. Otherwise, it will produce a true. And then for the not, it simply takes the opposite of whatever its input is. So when A is false, you get a true when you use not, and when A is true, you get a false. Right, so these make a fair bit of sense if you think about how we would use them in English language. For instance, if I say you need to take out the garbage and make your bed before you can go outside and play, then both of those things need to occur before you're able to do the following action, versus if I say you need to take out the garbage or make your bed before you can go outside and play, then you only need to do one of them, right? So the way that we think about them from English language also follows how we would use them within Matlab. The other thing that you need to be aware of when you're using logical operators to create conditional statements is the order in which Matlab will perform the operations. So we called this order of precedence when we talked about arithmetic operations. We also have an order of precedence when we deal with logical operators. So the operators with the highest precedence are the relational operators. So basically, any comparisons are going to be performed before any other logical operators. Then we have the not, followed by the element ones, which we'll talk about later when we deal more specifically with arrays. And then we have our ands and ors. Okay, so basically, a relational operator will occur first, then a not, and then your and or comparisons. The other thing to note is that all of these operators actually have a lower precedence than your mathematical operators. So any mathematical operations will take place first before any comparisons. So let's take a look at using some of our logical operators in constructing conditional statements. So let's assume that we have three variables, a, b, and c, which have values of 2, 3, and 5 respectively. What we're going to need to do is determine what the resulting value is as a result of evaluating these expressions. So let's get started. So the first one, a is greater than b. That's pretty simple. A is 2, b is 3. 2 is definitely not greater than 3, so that would result in a false, or a 0. We have a is not equal to c, so a is 2 and c is 5. 2 is definitely not equal to 5, so that would result in a true. Next we have a less than or equal to b. So a is 2 and b is 3. 2 is definitely less than or equal to 3, so again we have a true. All right, so now let's look at some that are a little bit more complicated. So we have c is equal to a plus b. Okay, so remember from our previous discussion that arithmetic operators have a higher order of precedence than logical operators, so the addition will occur before we do the comparison. So in this case, a is 2, b is 3, that gives us 5. C is 5, so we have 5 is equal to 5, and that's true. Now starting to combine some of these logical operators, we have c is greater than a and c is greater than b. So let's break this down into two parts. So c greater than a, so 5 is greater than 2, so our first part is a true. 5 is also greater than 3, so the second part is a true, and we have an and, so that's true and true would give us a true. Next we have, again, c is greater than a. We saw before that one was true, and now we have a is greater than b. 2 is not greater than b. We actually saw that in the first example there, so that would be a false. And now because we have or, true or false, as long as one of those is true, you would end up with a true. Okay, now getting a little bit more complicated again. We have a is less than or equal to b. We saw that on the third one there. That's a true. We also have c equal to 5. So c is 5. So that one would give us a true, but now we also have a not, which gives us the opposite of that. So we would end up with a false. So now we have true and false, and if you remember for the and, it's only true when both of them are true, so we would end up with a false. And then one last one. We now have a is less than b, or b is less than c, and we're notting the whole thing. So let's look at what this one comes out to be. So a less than b, 2 is less than 3, so we have a true. 3 is less than 5, so our result here is also a true. We now have true or true, so total here we have a true, but again now we're notting it, so the not of true is a false. So there's one last thing we need to talk about relating to conditional operators, specifically relating to the relational operators. So if we look at the statement that we see here, 15 is less than a and is less than 25, how would we interpret that? Well, we would interpret that as being true only if a is between the values of 15 and 25, right? We write expressions like that all the time in math. Unfortunately, it doesn't work the same way when we deal with Matlab. So in Matlab, this expression is going to be true no matter what your value of a is. So why is that? Well, it's because of the order of operations that Matlab goes through. Okay, so we know that when things are of the same order of precedence, in this case we have two less than, so they're the exact same operator, Matlab will perform the computation from left to right. In this case, it will perform the first less than comparison initially, so we would only look at is 15 less than a. If that's true, or if it's false, it doesn't matter, it's going to result in a 1 or a 0. That value then is compared to the value of 25. So a 1 or a 0 is always going to be less than 25, and thus we get a true no matter what the value for a is. If we actually want to do that comparison to see if a is between the values of 15 and 25, we have to break it up into two separate expressions. So we have to first check to see whether a is greater than 15, but we also want a to be less than 25. So we do both of those comparisons. 15 is greater than a, 15 is less than a, and a is less than 25, and we combine them with the and operator. In this case, that Matlab expression would be true only when a is between 15 and 25. So that brings us to the end of this video. Hopefully you now have a little bit of understanding about some of the different logical and relational operators available within Matlab.